Okay, hi everybody. Welcome to today's workshop. This is Introduction to Version Control with Git and GitHub. And this is a workshop in the UVA Library Research Data Services workshop series. So I'll do a quick introduction. So my name is Eric Perper, and I've been here at UVA since 2017. And I work in the Brown Science and Engineering Library. So here is my email address, and I'll make sure to put this my contact info and also the URL to this GitHub page with the workshop materials. I'll make sure to put those in the notes for this video. So like I said, I'm a part of a group called Research Data Services, and here is our homepage. So basically, this is a group in the UVA library that helps people with the research process. And that looks different ways for different people. But part of what we do is help people with programming related stuff. That includes data related issues, data wrangling, data visualization, writing code, mostly in R and Python. Also, we have a service available called the StatLab. So if you're having struggles with like a data related issue, writing some code, doing statistics, etc., you can get in touch with us. So again, I'll make sure this info is available in the notes for this video, but you can contact us and either email, set up an appointment to meet via Zoom, an in-person appointment, or you can visit us for office hours. So we have lots of ways you can get in touch with us, and we can meet with you either one-on-one or in a small group. So if you have future questions, please reach out to us at the StatLab. So I'm going to skip through this schedule here. This will probably be outdated by the time you see it. So, okay, so before we get into the material for this workshop, a few things that you need before we get started here. One is a GitHub account. So if you go to github.com, I'm already signed in, but you can create a free account easily in GitHub. It takes just a few minutes to do. So create a GitHub account if you don't yet have one. And you need a text editor or IDE. So this is any text editor you like to use. This can be something you use for programming already. It can be just, really anything. I'm actually going to use just the most bare bones text editor available on a Mac. It's called TextEdit. It just looks like this. It's completely bare bones, nothing fancy here. I bet you already have one installed by default on your computer. And we also need Git. So if you're on a Mac, you most likely already have Git installed by default. If you're on a PC, I've got a link here to install what's called Git Bash. So, not to get into the weeds too much, but Git requires a Unix or a Linux command line in order to run. So the Windows default command line tool or terminal is called the PowerShell, or just the shell, something like that. And it doesn't have the same commands. It doesn't work the same way. So I'm asking you to install Git Bash. And it's a small client that runs on your computer that is like a Linux command line client for Windows. I will also put these links in the show notes. You'll be able to go here to the Git Bash site. You can download for Windows. Again, like I said, if you are on a Mac or Linux, you probably already have this installed. But I have some links for where to install these. Okay, so our goals for the workshop today. So we're going to learn some background of version control, a little bit of why it was created, what it's used for, and so on. We're going to walk through some basic Git and GitHub workflows, and then we're going to talk about how to get help in the future. So unfortunately, you're not going to be an expert after this simple workshop today. This is kind of like just a nice addition to your programming skills. So version control, which we'll talk about why we do it next, it's not really a language in and of, it's just an addition. It's just a way of tracking your code, managing your projects and things like that. It's not an end in and of itself. I'm sure there are some people that dive really deeply into it. I generally use just the basic functionality. So that's what we're going to cover today. All right. So let's start from the beginning. What is version control? So basically, version control is the practice of tracking and managing changes to software code. And version control systems are software tools that help software teams manage changes to source code over time. So version control software keeps track of every modification to the code in a special kind of database or file. So if a mistake is made, you can turn back the clock and reset your code to what it was, or compare earlier versions of your code to help fix the mistake while minimizing disruption to all the team members. So this is helpful if you're working in a team setting. If you're not working in a team setting, you can still use this, and I suggest you do, as a backup to your work. So a brief history of version control. So the model of version control in the early 2000s was a centralized model. So basically there was a central server where all the code and all the versions of the code were kept. So the centralized version is based on the idea that there's a single central copy of your project somewhere, probably on a server, and you commit your changes to that source. So when you check, so if you were a programmer, you basically check out a version of the code, and then your friend checks out a version of the code, and then you check them back into the central source when you're done working on your part of the code. So there's one major problem to that. Well, a couple major problems. One, it's difficult to work on collaboratively. Two, if there's one central source of the code, in the event of a catastrophe like a power outage and your server goes down, something like that, it's possible you could lose the entire project. And that's not good. So Git was created in 2005. So this is a distributed version control system. So we still probably do have a server, but everybody that's working on the code has checked out or copied a complete record of the code. So you have a complete record of the code and all the changes in the code. Your friend has the same. So this was created by Linus Torvalds for Linux development. So if you don't know who Linus Torvalds is, he is sort of the godfather of Linux, which is, there's many flavors of Linux, but basically open source operating systems, not just Mac OS or Windows. So in software development, distributed version control is a form of version control in which the complete code base, including the full history, is mirrored on every developer's computer. And this is the system or the model that we're working with today in Git and GitHub. So we'll talk about the difference of Git and GitHub shortly. So why is this important, this distributed version control system? So there's a lot of benefits, but the key points are that there's a single source of truth across teams, across your code and other assets, which means your other files, data, pictures, stuff like that. Basically, everyone's working from the same code, if you will, or the same project. There's traceability for every change ever made, meaning you can go backwards in time, go forwards in time. And this allows faster speed of development, especially if you're working on a team setting with other people. So let's go over a couple key terms really quickly. One, Git. So like I just mentioned, Git and GitHub are not the same thing. So Git is a version control software, and it is installed on your local machine. Like I said, they're not the same, and they can work independently of each other. So Git is what you're using on your computer, your laptop, your desktop to track. It's installed locally and it tracks your changes locally. So GitHub GitHub is now a for-profit company that's owned by Microsoft. Microsoft bought GitHub, I don't know, 5 years ago or something like that. So basically, it provides cloud-based hosting of repositories. GitLab is a free and open source alternative to GitHub. It's pretty similar. Maybe you feel like your code shouldn't be behind a Microsoft product and things like that. Some people feel really strongly about open source software. So a repo or a repository, this is the basic unit in Git. It's a project, if you will. So this is the basic unit in Git, and a record of all the changes are contained in that repository. Forking and branching, we'll talk about those later. We'll get to those later in the workshop, so don't worry about those now. I've got a link to some documentation here about all the vocabulary words and things like that in this Git glossary and Git handbook. Okay. So we don't need to download anything or any of this code, I suppose. It's all contained here. No, I'm sorry. Actually, we do. Let me back up. I take it back. So before we get into it today, yeah, we need to download the source code here from this repository. Okay, so to do this, let's scroll to the top of the page, and in the top right, there's this green code button, and let's click on that and then download zip. So this will be downloaded to your downloads folder. So I'm going to minimize these for a minute. I'll get rid of some of this stuff. And let's see. So I'm going to open my downloads folder. Downloads. So this is called Intro to Version Control main. So I'm going to drag and drop this onto my desktop because that's where I like to keep temporary stuff. And then to extract it, you can double click just like that. Or you can right click and open with on a Mac. So if you're on a PC, you need to right click and this will say extract or extract here, something like that. Okay, so like I said, back on my desktop, yours might be in a different place. We've got all the files that we are going to work with today. Really, it's just this testcode.txt file, but we'll get to that later. Okay. So let's scroll back down to this section. Let's get started. Okay. So now we're going to open up our terminal. So if you're on a Mac, it'll look like this. I have mine docked down here in the bottom because I use it frequently. So you may have it down there, you may not. If you don't, you can go to your Finder spot or a Spotlight search up here and look for terminal, and it will open. So if you're on Windows, open up Git Bash. It won't work if you open the normal Windows shell. The commands are not the same. So you need to be using Git Bash. So the way this is going to work today, I'm mostly going to just follow along with what I've got here in the GitHub repository. So all these gray boxes, these are code boxes, if you will. So most of what's happening is going to take place here in the terminal. So I'm basically going to follow along here and just write these commands in the terminal. So let's start here to make sure that Git is installed and working correctly. So git -- version. So I've got version 2.37. You may have something different. I don't think it really matters for this workshop today what version you have. As long as you have something, if you got an error saying that Git not found or something like that, you either didn't install the Git Bash client, or maybe you're on a Mac and it was not installed by default. Go back up and install Git before you continue. Okay, so next we're going to set some config values. So I have done this already, so I suppose I can do it again. It won't hurt. these are your name and your email. So this is your contact info. So when you're making these commits, which you'll see later, this information will be attached to your commits. So let's type these together. So git config. And I don't know what all these flags are, like this global flag. Don't worry about it too much. So instead of your name, it's just going to be okay, and git config. Put in my name and my email address. So if I do git config -- list, we can see these. So my user name is Eric Perper. My user email is ep9k@virginia.edu. You may have other information in there. If you have a long list of stuff and you can't get back to the normal command line there, press the Q key. That's for quit. Okay. So we're going to walk through a couple common scenarios today. So the first scenario is one to make the point that Git and GitHub are separate. So first we're going to make a repository from scratch, or a folder, if you will, and we're going to track it with Git. So this is making some files and stuff on our local computer and then tracking it with Git. Okay. So in order to do this, we also need a little bit of just basic knowledge in the command line. So first of all, we need to see where we are in which working directory we are. Where are we in our file structure? So if I type pwd, this will tell me print working directory. That's what that stands for. I am basically at my root. It's just my username on this computer, my user profile, if you will. And to see what this folder contains, you can type ls. I think that stands for list or something like that. So these are all the folders and files that I've got in my working directory. You see the desktop is one of those, my downloads folder, etc., etc. Intro to version control, that must be an old one. Anyway, that's what's located in this folder. So if I want to navigate around my file directory, I'm going to do that. For example, I'm going to go into my desktop. So if I do cd, that stands for change directory, and then cd desktop, this will take me into my desktop. So if I type ls again, these are all the folders and files that are on my desktop. And I'll show this to you again shortly on the desktop. Okay. If you want to go back, if you want to go backwards one directory, you can do cd space ... And that'll take you up one level back to where your working directory was. So I'll do cd desktop and go back to the desktop, which is where I want to work for this workshop today. Okay, so my working directory is my desktop. You may have some other place where you like to work with temporary files and stuff like that. So let's do this together. We're going to make a new folder or repository, if you will, on our desktop. So let's do this. Make dir test git. Okay, so just to show you what I've done, let me minimize this stuff for a minute. I should have a test git folder on my desktop, and there it is actually, test git. So this is actually doing the same thing if I right-clicked here and went new folder and called it my test folder. But we're doing it with the command line today because, when you're working with GUIs, like these graphical user interfaces, there is eventually a point at which you don't have control to do something that you might need to do. So we're going to do these with the command line tools today mostly. Okay, so I'll back up one more time. As you see, there's nothing in here yet, just an empty folder or empty directory. Okay, so now let's cd, or I could do ls first. And you see now there's a test git directory in my desktop, which we just saw. So I will cd test git. Okay. Again, ls, there's nothing in there. So I'm going to make a new file now. Touch testfile.txt. And if I type ls one more time, now there's a test file in my folder, which there's nothing in test file, but the file does exist. So if I minimize that again here and go to test file, there it is. Okay. So now we're going to make a change to the test file. So open up test file in any editor of your choosing. You could use TextEdit like I'm going to use, Notepad, Notepad++, PyCharm, RStudio, whatever you want to use, it doesn't matter. So I'll go back to my desktop, and what was it called? Test git and test file. So blank file. There we go. So I gave you a couple lines of code. It doesn't even matter what you write, to be honest. Just write something in your file. You could just write some nonsense. You could copy and paste the code that I've given to you over there. It really doesn't matter as long as you write something in there and then file and save. Okay. So now we've started a repository or a directory, and we need to start tracking it. Okay. So let's see, just to prove a point, make sure you're inside the test git directory. We've already done that. You can see that test git is right there next to my cursor, next to my prompt. So now we need to track this code with Git. So again, this is the situation if you had just created a new project from scratch, put some files in there, that sort of thing. So we're going to do git init. Okay, so it says initialize empty git repository in, and this is the place, this is the file path to my Git directory. Okay, so if I do ls again, I only see the test file. And again, if I open it there, again, in the test git folder, there's only the test file. Well, actually, there is more. It's just hidden. So if I do ls-la, this is listing all. So these are listing the hidden folders or directories in my directory, in my folder. Or if I do, I like this view a little better, ls-a, it shows me that there is actually a hidden Git directory in there. And I could cd into that. So cd git or cd.git. And there's all sorts of stuff in there. This is all hidden to you because they don't want you messing with it. To be honest, I've never messed with it myself. So I'm just going to cd ... and go back into my test git directory because I don't want to touch that stuff. And you shouldn't either. But you should know that it is in there. Okay. So now we're ready to make a commit. We've got a project. We've got a file in there with some stuff in it. And now let's talk about the workflow of making a commit here. So we got our working directory, which is test git in this case. So it's a two-part process to make a commit and store those changes. So you stage your changes and then you commit them. And then you kind of reset back to your working directory as it was. So the way I like to do this, first, let's do git status. Okay, so if you did git status and said like, this is not being tracked by Git or something like that, you did not do the git init step, which is up here. Where is it? Oh yeah, git init. You did not do that. Go back and do that. Okay, so, oops, sorry. So we've checked the status. So this is saying no commits yet. That's true. We have not made any commits. We have some untracked files. We have a test file that has not been committed yet. So the way to do this, the way I do this, is now, so we've checked the status. Let's do git add a. So that's adding all the changes to our files to the staging area. And now git status again. So now you can see still no commits, but ready to be committed. So these were untracked files, and now they're ready to be committed. So we don't have to do this, but if you made a mistake, you can undo that. So if you saw something in here you didn't want to see, you could do git reset test file.txt. And if I do git status again, we're back to where we were, untracked files. So just a pro tip here, you can use your up and down arrow in your keyboard to go between to toggle between your previous commands. So I will do git add a again. Okay, and now we're going to make a commit. So git commit -m and a message about your changes. Okay, so this message is required, and you'll see why we're using it later, because this allows you to say something. It should be short and concise, but it allows you to say something about your changes that you just made. And you want to commit early and often. Really, any meaningful change that you make to your code, you want to commit that and later push it to GitHub. We'll get to that next. That's because it makes it a lot easier to troubleshoot later. If you've made 15 changes to your code and then you save over it, well, let's say one of those changes was a mistake. Well, you still have to revert back to your code previous to that last save. So you might have lost 15, or you might have lost 14 good saves, but there's one bad one in there. So you lose all of them effectively. So we, hit enter. So git commit, and then a message about your changes. It gives you a little bit of information here. One file is changed, one insertion, and now we can do git status again. And we have nothing to report here because we've tracked our changes locally in Git. Okay, and the last thing you could do is git log. So this is what you'll see later when you're looking back through your changes. So it's got a commit hash key, which is just a unique identifier for that commit. The author, my info that I put in earlier. The date, it's today is January 11th, 2024 at 2:50 p.m. And then this is the commit message that I posted or added in there. Okay. So let's minimize that for a second. And I will close this, and I will even delete it. That was just a very quick example of how you can track your changes locally without GitHub. So the next example is probably how you'll be using it in reality, because you want to track your changes locally, but then you want to push them to a remote repository, which in this case is GitHub. Okay. So for the next scenario, you need to fork my repository. Okay, so let's just pause where we are here. Scenario 2. Okay, so we're making a fork. Okay, so what is a fork? It is, I've got a definition for you in the middle here. See if I can find it. There it is. It is a personal copy of another user's repository. So you are not making changes to my repository. You're making your own copy of this repository, and you're going to make changes to it. So if you try to do this without forking my repository, it's not going to work for you. So in order to fork this repository, if you scroll to the top of the screen here and you find this fork button, go ahead and click that. And the owner should be your GitHub username. And just leave the repository name as it is and click Create Fork. So it's going to then take you, I'm not going to do this, but it'll then take you to your own version of this repository. It's an exact copy. So let me go back here. So at the top of your screen, it should say like, your name and icon, and it'll be called Intro to Version Control. All right. So let me scroll back down to where we were, scenario 2. Okay. Yeah. Scenario 2, tracking an existing remote project with Git. All right, so we've already, we forked this repository. Oh, okay, yeah. I'm sorry, let's back up here. I was a little bit off. So what we did on the desktop already, this intro to version control main, let's get rid of this. I was wrong earlier. My bad. Get rid of that, trash it. So we're gonna clone this repository. So it's going to be your repository that you are cloning, not my repository. Okay, whoops. Okay, so let me just make a new terminal here. So I'll do new window. We're starting from scratch. Okay, so let me navigate back to my desktop, cd desktop. Okay, so on here, we do not have this repository yet. Okay, so the way we do this, so this is the situation where you are cloning a repository that's already at a remote source. In this case, that remote repository is on GitHub. Okay, so the way you do that, whoops, I'll go back to the desktop, cd desktop. Okay, so this is git clone, and then the URL. Okay, so to get that URL, let's scroll to the top of the page here. If you click this green code button, and you want to be on the HTTP tab, copy that URL right there. So I'll copy that, go back to my terminal, git clone. And this should have your username. It should not be my username. This should be your fork that you're cloning. So it'll say cloning intro to version control and give you some other information about it here. And then if I go to my desktop, there is my intro to version control folder. I told you incorrectly at the beginning of the workshop, my mistake. And this has the same files that we have seen earlier. Okay. So now let me scroll back down to step 2. Yep, here we go. Okay, so we just cloned this git intro folder. So let's navigate into that. So if I type ls, I can see this folder is called intro to version control. Yeah, so I will cd intro to version control. Okay, and if I type ls, you can see I've got all those files in there. It looks like I got a typo. At least my this repository used to be called git intro. It is now called intro to version control. So if you try to do cd git intro, it's probably not going to work because this folder is called intro to version control. And I can see that if I look at it on my desktop right there, intro to version control. Okay. So again, looks like I'm just checking to make sure that this is being tracked by Git already. So ls-la, and there's some other folders in there, but yes, it is already being tracked by Git. And we can also view information about the remote repository. So git remote-v. This is handy because sometimes this stuff gets messed up and you can't push to GitHub the way you think you should be able to. So anyway, this is where the data is fetching and pushing to. So that means we're getting the data from this URL, intro to version control, and it's also being pushed to that URL, intro to version control. So we're going to come back to branches later, but I just want to I want to quickly introduce the home branch, or the main branch, I should say. So if we do git branch -a, this is going to show the branches that we're working on both locally and remotely. So locally, we have a main branch. That's correct. Remotely, we only have the main branch as well. So we'll get to branching later, but as of now, we're only working on the main branch. So, all right, now that we're set up here, let's check the status of our code. So if we do git status, you can see we have not made any changes to the code. Everything's up to date. Okay, so now let's minimize this and open up intro to version control and open up testcode.txt. And this is just a simple text file. This is Python code, but you don't need to know anything about Python to do this. Just make some changes to the code. I am going to just delete the multiply function, and I will save that there. You can make any change you want. You can write another function. You can just write some nonsense in there like that if you want to. I'm just going to delete what I had in the multiply function, and I will save that. Okay. Okay. So let's do this one now, git diff. Okay, so this is showing you the differences in the previous version of the code and the current version of the code. So red means I've deleted code. So it's showing you I've deleted these 2 lines of the code. I generally don't look at it this way very often, but some people like this. So now we're going to make a commit locally, and then we're going to push those changes to our remote repository, which is GitHub. So the way this works is just like we did before. So we'll do git status, and you can see I've modified the testcode.txt file. So we'll do git add capital A, git commit -m, and I deleted the multiply function. Okay, so I'll do git status again now. So you can see we have pushed our changes locally, or I'm sorry, we have committed our changes locally. Okay, now we're going to push them to our remote repository. So yeah, so the first thing you want to do is git pull origin main, git pull origin main. So this is in the situation if you were working on this collaboratively with a friend or other, colleagues or whatever. So they could have been working on their code while you were working on yours. In this case, that wasn't happening. So you see that there was basically no information there. It just said everything is up to date. However, if somebody had committed other stuff in the meantime while you were working on your code, there would be some updates about what you've pulled into your repository. Okay, so you want to pull and then you want to push. At least if you're working collaboratively with people, you always want to pull before you push. So now we're going to push. So git push origin main. Okay, and it'll tell you some. I don't really know what all this stuff means, to be honest. But now let's see if this has taken effect. So we'll pause right there before the branching section, and I'll scroll back to the top of the screen and refresh this screen. So you see here, testcode.txt, 1 minute ago, I deleted the multiply function. So that change in Git was pushed to my remote repository. And you see it right there. Okay. So let's go back to branching. Actually, before we do that, where am I here? Branching. So I know it's kind of long-winded to do all that step by step here, but let's show you how it works in practice. So let's say I'm working on my code. I'll just write a new function here, def multiply A and B. And this is Python stuff. You don't really need to worry about this. Return A times B. Okay, so now I'll save that again. So I've just made some changes to my code. That's all good. So I'll do git status. So you see I've made my changes. Git add A, git commit M, and made multiply function. Git push. So there it goes. I push it to GitHub. And if I refresh, then you can see I made the multiply function. And I made that commit just now. So there you go. Okay. So let's go through branching quickly. And then we'll wrap it up. Yeah. Okay. So far we've only been working on the main branch of our repository, and that's not really how you should be doing this in your day-to-day workflow. So this is where branching comes in. So especially if you are working on this with collaborators or somebody from your lab group or other people in general, you should be using branches. So common workflow is to create a branch for your desired feature and then work off that branch. So a branch is a parallel version of the code repository. All right, so let's see this in action. So I'm going to create a branch here. So I'll do git branch dash A to see our branches. So we only have a main branch. Okay, so now let's make a calc divide branch. We're going to make a divide function. So git branch calc divide. Okay. And now git branch A. So you see, locally, we have a calc divide branch. We do not have one remotely yet, but we'll get to that later. So git checkout calc divide. Okay, so I've switched to the calc divide branch. So now if I do git branch dash A, again, you can see the calc divide branch is lit up in green locally. I'm no longer on the main branch. Okay, so let's go back to our file that we were working on, and I will make a divide function now. So def divide A and B, A divided by B. And this thing likes to capitalize, but that's incorrect. So anyway, I will make my changes. I've saved my changes. Okay. All right, so let's do git status. Okay, same as always. I've modified the test code file. That's good. So git add A, git commit M, added divide function. And then git, okay, so now this is important here. So we need to push this to the remote repository, but we're pushing it to a branch that does not yet exist on the remote repository. So in order to do that, we'll do git push U. Don't worry about the U flag. Just go with it. Origin calc divide, because our branch is called calc divide. Okay. So now let's do git branch -a again. So you can see we've got a calc divide branch locally. We have a calc divide branch remotely. And then git push branch to remote repository. Just to illustrate that point, so it is giving me some updates here. Calc divide branch has pushes. So if I hit this little drop down, or actually if I refresh my page, so you see we're on the main branch right here. If I drop that down, now I have a calc divide branch. Okay. Where was I? Push branch to remote repository. We did that. Okay. So now we want to merge these changes locally before we push them to the remote repository. Okay. So now we're going to check out the main branch again. Git checkout main. Okay. So just to reiterate this point again, if I do git branch -a, you see we're back on main. Earlier I was on calc divide, right? And in fact, if I open up my test code file again, you see there is no divide function. That's because the divide function exists on the calc divide branch. It does not exist on the main branch. Okay. But now we're going to merge calc divide with main. Okay. So the way you do this is, pull any changes that have been made to the main branch. So git pull origin main. So the origin, I haven't said this yet, the origin is GitHub. Basically, we're pulling any changes that have been made to the remote repository, which is GitHub. So no changes have been made in that time because I'm just doing this alone. Okay, so git pull origin main. Now we're going to merge these branches locally. So we're merging them locally first. So git merge calc divide. So it's showing the code changes that have been made. Okay. And then I can look and see what I've merged in another way. Git branch merged. And we merge them to main. Calc divide and main. So if I were to if I go back to my file here that we were editing, this is unsophisticated. A lot of modern editors will automatically update. But if I close this and reopen it, you can see now again I have the divide function. That's because we pulled it from calc divide into the main branch. Okay. Okay, so now we're going to push our local changes on the main branch to the remote main branch. So git push origin main. Okay, so those have been pushed to GitHub. Okay. So now we want to delete our branches. Once we've made all our changes and the code is good to go, we want to delete the branches. So first, you want to delete that branch locally. So if I do git branch -d, the -d flag is the delete flag, and calc divide. So it says deleted branch calc divide, okay? If I do git branch -a again, you see locally I only have main, but calc divide still exists remotely. So now we want to delete that branch remotely. So git push origin, and origin is GitHub, remember, delete calc divide. Okay. So now if I scroll to the top of the page, and yeah, so you can see the changes that I made, added divide function 5 minutes ago. You see the calc divide branch doesn't exist here anymore. So that's the basic workflow of tracking changes with Git, making a commit, pushing it to a remote repository, which is GitHub, and also branching. So that's the quick workflow. So in conclusion, I've got a quick other resources section here. So one thing I've got is I want to jump around a little bit here. So basically, I created this video based almost completely on a video from my favorite YouTuber. He's a YouTuber with mostly he makes videos on Python programming and also related topics like this. So I've got a link to this guy's video. So Corey Schaefer is just a guy with a YouTube page, and he's got amazing videos on how to do all these basic programming topics and things like that. I based my video on his because I didn't think I could do it any better than him. He explains it really thoroughly, really clearly, and it's one of my go-to pages. If I'm learning a new library in Python, a new programming concept, etc. Corey Schaefer has a video on that. And he's got an entire Git series of videos. Let me see if I can. Yeah, there we go. So a few of the others are popping up in the algorithm here. Anyway, he's got a whole series of Git videos, which I still refer to pretty regularly because they are really thorough, really easy to follow. I'm going to leave it at that. Yeah. So in conclusion, thank you all for attending. If you've got any future questions, please feel free to reach out to me. My email is eperper@virginia.edu, and I look forward to talking to you in the future. Thank you.